Thank you, everybody, for staying until now, and you're still here, so thank you. So I'm here to talk about building a cloud-native data pipeline for your real-time AI and machine learning apps. May I ask too, actually, I'd like to just understand, how many of you are already doing some AI applications at this point? Okay, there's a few. Yeah, actually, yeah, a few. Okay, so that's good, but I'm still going to talk maybe a little bit about Gen AI a little bit, just because it's kind of such a hype right now. So I'll talk about that. And also, too, this is a KubeCon, so it's more about cloud, all that infrastructure. So I'm trying to also kind of make it relevant, too, like talking about data pipeline and for cloud-native type of applications. So thank you. And okay, let me start. Okay, I want to make sure. Okay, so this is the agenda. I'm going to have a really quick introduction first and then talk about event-driven world and AI, and then looking into the data pipeline too. And then also, as such, I want to kind of bring this up because I presented this talk with RisingWave before. How many of you actually are working also, say, with open analytics type of software, like RisingWave maybe? Yeah, somewhat like, or like, there are other ones too, kind of more like real-time data analytics, such as like Bytewax and things like that too. Also, one is called Fennec. I also did a talk on that earlier too. This is more about data transformation in the data pipeline kind of space. So anyway, but RisingWave, because I pair with Ray Yees, he's the product manager for RisingWave last year, actually also at KubeCon, and I think that was in Denver. I forgot where it was, but that's where I talked. So today, I'm going to talk a bit too about RisingWave, and then just kind of conceptually building a ChatGPT data pipeline to what I kind of have in mind. But because of so short it is, and probably won't have time to do a demo, but I'll leave you with my contact information because I also try to do some online demonstration and live stream all of these things too. So that's the plan. So a quick intro of myself first. So picture is worth 1,000 words. I'm currently actually helping out, I'm on sabbatical, and I'm actually helping out a nonprofit called AI Collective. And if you're interested in it, I'll do a bit of a shameless plug, kind of advertisement for them. It's a grassroots organization, but like through a lot of meetups and that type of stuff. And it's not only for technologists, it's also for sometimes like for startup founders, investors, and all of these things. So, but I myself, though, I come from a software engineering background. I was an engineer for maybe 20 years or so, and then I became a developer advocate at IBM. And that's where I actually started working more and more with real-time data streaming in that kind of line of business. And also like working with Akka a little bit, if you're familiar too with Lightband, Akka, messaging, broker, all of these things, and then slowly into Apache Pulsar as well. And then I kind of joined a company that does consulting, but then it didn't work out. So anyway, so now I'm on sabbatical helping the AI Collective. I just became the VP of Global Expansion of Western Hemisphere too, but otherwise too, I'm based in Chicago, and I also run the Chicago chapter for this organization too. And what else? And I also, actually, I came more from a Java background, so I also run the Java users group in Chicago as well. May I ask you how many of you are developers here? I'm just curious too. Okay, yeah, great. Oh, quite a few. Anybody do Java too, by any chance? Oh, actually, quite a few. Thank you. That's great. That's really great to know because as such, right, working with machine learning, I realize it's primarily Python, but it really doesn't matter these days. So. Okay, so that's me, and then that's how you can get a hold of me, all of these things. And my interest, though, is a lot into like distributed systems and streaming and that side of things. So, okay, so I'm going to start kind of talking a bit too about the event-driven world and then AI too. At the heart of AI is really data. And so it's also data itself, as we know. It's not static. Nothing is static in there. And it's really about flow of data in many directions, too. So now I kind of wanted to talk a bit, too, about working with data and tools. So architecture level, we can be talking about event-driven type of architecture. And also, too, essentially, too, data is kind of a very interesting thing, right? As we know, this is also data on Kubernetes. And As such, we want to try to understand data in different states and handle it accordingly. So it can be data at rest, which means that data is in storage, some form of storage, a database or file systems, or it can be in transit, like in a network communication kind of mode, traveling from one node to the other, or it can also be in use too. You're extracting data from some storage or somewhere where you need to perform some transformation to it. And then there are different techniques that can be like event streaming, event messaging, and event sourcing, and CQRS. Those are kind of help to work with data too. But let's kind of take a bit of a look into more generative AI type of streaming usages. I just wanted to point out too that if we kind of think about event streaming, it's actually more common than we think. But I think as developers, some of us are developers too here, a lot of you. And when we first started learning coding, we're kind of doing things more like the way that's easier to do. Meaning it's not like easier, but we like things a bit more predictable type of patterns and what to do. But anyway, why I bring this up is that because I want to talk about like streaming, like it's more common than we think. Because if you think about it, right, we like in a generative AI types of usages, we're now working with some ChatGPT platform, let's say OpenAI, all of these, they have sites where you can interact with the LLMs and all of these things through prompts. And this is how we're doing it. We're sending prompts in the form, like it's basically command to send to the LLMs. And it can be on the command line or in the browser, mobile app, anything like that. And they are all unstructured data as well that actually will be sent, is eventually send it over to the LLMs like that. So what I'm talking about this is because, as we can see, event streaming occurs in many things. And it's also like less kind of not as easy to do. But yet, too, the benefits of such is it brings that real-time kind of capability to interacting with commands coming in rather than doing it in a batch fashion. And so now in generative AI type of usages, too, we can also kind of look into intermediary steps, too, of Gen AI types of application. Let's say during RAG operation, and that's the retrieval augmented generation. In that operations, too, there are also different sources that we're going to have to ingest the data in order to ingest it, and those are the data that's not being used to train the LLM. Because as such, the LLM is also actually quite limited. I mean, it is as powerful as it seems. It seems to understand things, and it's been trained on a lot of data. But the data itself very often is very outdated. Like, just think of how ChatGPT, when it first came out in November of 2023, it's actually the data from like a year-old data, because it takes a lot of time to train the model itself. So then we are relying on RAG to augment what the LLM doesn't have. So all these two, if you kind of think about it, we need to be feeding the data sources into this pipeline to process data. So all that too is also can be thought of to, we can use techniques that's like event streaming type of mechanism to kind of feed the data into this whole ecosystem too. And of course, too, during this RAG operation too, it's basically the RAG will be taking the request, and then it also will augment the prompt, like will also enhance the prompt, because the RAG is also like extracting data, let's say from a vector database, and to enhance your prompt, and then eventually send it over to the LLM. And then also too, then the LLM will process, taking this command process and sending back a request, a response back to the user. But before that too, essentially too, all these, it gathers all the results and then send it back to the requester, and all that also can be streamed back to the requester as well. So just kind of point that out. So benefits of this event-driven approach is basically it can handle this dynamic nature of data and its flow patterns too. And helps too to help with event streaming is very much because we're now like detaching all of the components. They are all individual. They are loosely coupled. So it helps with asynchronous style of communication, and also helps with scalability and flexibility, because now you can scale, let's say, producer of the messages easier, and also the subscribers as well. So they are not like, tightly coupled in that case. And it also helps too in some cases, right? When we're working with events, then you can have even like cases in which you're working with AI agents. Agents can ideally be, each agent is very specific, working with certain AI models. For example, I want to be doing coding. I'll be interacting with an LLM that handles coding like a Codex LLM. And then another model is basically I'm processing like video data. I'll be working with another LLM that specializes in that. So it kind of helps to this event-driven approach. But just be aware too, it can become more difficult to debug and also harder to track all of this flow of the calls and the data it carries too. So we need to also do more work in terms of observability as well. So now let me kind of take a little bit, zoom in and take a look into the data pipeline too. Just want to understand like what is a data pipeline. It's basically a series of processes that transport the data from one or more sources to some destination, right? Such as like a data warehouse or like a data lake or some application or intermediary kind of steps too that will require the data to be further transformed as well. So this data pipeline becomes like necessary to kind of, or actually it becomes necessary, we need to monitor and manage the flow of this data too. So then we make sure too, in some cases when you're transforming the data, you can be updating the format as well, all of these things. So it can also be, basically you ingest the data in, like that's from the source, and then you can then pass the data on to another step, which is doing transformation, like to another open analytics software or doing reporting or machine learning, these kind of use cases too. So we'll take a look then into data ingestion too. This is like the process of collecting and importing all of the data and transferring from some sources, various sources, into some storage or processing system too, where it can be further processed and analyzed too. It's basically first step in any kind of data pipeline. And then it connects the data sources to analytics platform. And then now all of these too can be done like in batch format or real-time streaming format too. So the kind of data ingestion, just wanting to talk about, it can be, again, it can be batch ingestion. So you process data in larger chunks and in some scheduled interval, for example. However, there's also much faster, more modern kind of data ingestion would be through streaming. So these are continuous real-time data flow for immediate processing and insights too. So for example, in stream processing as well, you can also like be leveraging on techniques such as like CDC that are change data capture. So basically too, if there are any kind of changes in the data, you set up those kind of capture feature in which there are changes such as like inserts or updates or deletes, all of these in real time. So if anything happens, then you immediately trigger some action to it. So in this case too, you guarantee that all of the data, the updates will be done in real time, and it's especially useful for some business intelligence that requires real time type of usages too. And then also too, we'll take a look too. I kind of mentioned in this talk too, I mentioned about Apache Pulsar because I worked a little bit with Apache Pulsar. And that's actually, the Pulsar is like similar to Kafka. It's like it makes use of a pops up type of mechanism too. So you have like actually a broker that essentially will be the ones that will be responsible for receiving the data from the producer and then also disseminating or distributing them by allowing subscribers to subscribe to the topics too. So Pulsar too itself, here it isn't, Apache Pulsar isn't, how can I say, like it came out actually after Kafka. Kafka came out earlier in 2010 or so, but Pulsar came out in about 2000, maybe 18 or 19 from Yahoo. And the thing is too is that it's because it came out after the cloud became more ready to a bit more mature. So it takes into account, for example, like making use of like multi-tenancy, things like that too. So it's kind of got some kind of advantages in terms of doing like cloud native type of processing. It doesn't rely on what Kafka has, right? If you work with Kafka, Kafka has this thing called, what is it called? kind of like often it slipped my mind, but they have the special way of indexing, right? So Pulsar doesn't make use of that at all because it already has all of its built-in to know it's internally like indexing all of these things too. So in other words, like you can be using Apache Pulsar to do your data injection and making use of your broker, sending your data, any kind of data changes be sent to some Kafka or Pulsar topic, just like you do it with Kafka as well. So that's like data injection. So basically over here too, I'm kind of mentioning about these are modern event streaming platform. So the idea is because of the way it is a pub/sub type of architecture, so it's allowing for high throughput and low latency messaging too. You can now also too, the thing is it doesn't restrict you to one type of languages, right? You can be doing in like Java to do a producer messaging, and also have a Python client to be actually picking up messages from your topic as well, or any other kind of language client platform that supports speaking to or picking data up from a Pulsar topic as well. So here too, I was just going to say you can also, for example, using something like RisingWave that can ingest all of these data too for real-time analytics as well. So, okay, that's the next thing. Just talking about, actually, one more thing. I just want to say why ingestion matters because it enables like real-time decision making and also support like event-driven architecture. And then in an AI and machine learning type of pipelines, it can actually supply like fresh data as well. So also too, because it is so like efficient. So you like say for example, if you're Java folks, you're doing a lot of microservices especially. So it helps too in terms of all of the communication mechanism as well. So just wanted to talk a bit too about data transformation in the pipelines. So data comes in, we're ingesting it, then we can also convert this data, the raw ingested data, into some meaningful structured type of format as well. You can do filtering and cleaning of the data, enriching it, all of these things as well, and even format conversion to like say JSON to SQL data, for example. So one note to kind of point out is that data pipelining versus like ETL, and some of you may also been kind of working with, especially the very experienced folks are working with extract, transform, load. This type of operations is similar to data pipeline, except then legacy ETL tends to be more disk-based or disk-based type of processing. So we are talking about modern ETL that would be replacing the disk-based processing with in-memory processing. So then it helps in near real-time processing as well, and it's much faster. So modern data pipeline, just wanted to kind of talking about, so data on Kubernetes, so that's kind of like what is matter in here is that we want modern data pipeline to be real-time and handling data processing and analysis. Also having a cloud-based architecture that's helping it to do auto-scaling as well. And also to the architecture itself, we can leverage on the cloud platform for fault tolerance as well. So if one node goes down, another node will be up, for example. Say, for example, like Pulsar too is actually very much support like fault tolerance as well because of the way it's developed too is already taken into account all of the cloud native kind of architecture to it. And also to modern data pipeline, we also want to make sure there's exactly once processing, especially cases if we're handling money kind of transaction. Like we do not want anything to be repeated more than once. If you get money out, you only take it out once, right? Not more than once like that. And also too, the management side also has to have maybe self-service. And also too, supporting like high volumes of data in many different formats as well. And also too, this modern data pipeline should be able to handle very efficient data pipeline development as well. So a cloud-based infrastructure is actually essential. Let's say with Kubernetes, able to do orchestration, all of these things. So you're syncing up, there's data that's flowing through the pipeline that they are exactly ones, for example, things like that, able to do architecture kind of tolerance, that type of stuff. So here too, I realize time goes by too fast, so just want to quickly point out RisingWave too is basically a stream processing database. So the thing about it is, let's say if you're already familiar with SQL, SQL, then you can actually use SQL. And the key to it is that it makes use of a materialized view. So you can actually use regular SQL if you're more familiar with that. Do all of these things using SQL to do your thing. And then basically, it will handle all of the real-time kind of data, all of the real-time analytics being done essentially too in their what you're going to say, yeah, in their like real-time processing. So it is the RisingWave. So also too, there's also real-time RAG with streaming database as well. Again, because I don't have too much time now, so I'm just going to quickly kind of page through a couple of things. Just wanting to say, stream processing is basically in today's fast-paced like business environment. So we want to allow business to make real-time decision too, and up-to-date kind of insights as well. Okay, so this one I already explained. It's a distributed SQL streaming database. So it also then, if you're familiar, there's also CAP theorem. So all of these two, RisingWave is also respecting the more like the not availability, more like consistency side of things too. So. Okay, RisingWave, some market focus and ecosystem, but there's also another one just wanting to point out too, is some real world use cases, because it's kind of not too much time, but just wanting to kind of point out too, for real-time kind of operation of data.
Sorry, I think you can take more time to explain it, right? Since this is the last talk.
Oh,
so you can take more time. You can go back.
Yeah. Oh.
If everyone will agree, I don't know if everyone will agree. Yeah, so we all agree.
Okay,
so take more time.
Okay, sorry. I won't, I know everybody's probably tired, but thank you, Divine. Okay, just, I realize, and okay, so I'll go a little bit more. So basically too, yes, just to be in line with the spirit of this conference about Kubernetes Cloud Native. So as you can see too, RisingWave itself too is a distributed streaming engine that also you can launch them into, they already have it like cloud native easily too. So you can also make use of that, and it's already kind of built in and work with the cloud, all of these things. And the thing is too, is that it also allows for RisingWave to be working with data ingestion platforms such as Kafka or Red Panda or Pulsar or all of these Amazon, this one with Amazon as well. So all of these other things in the cloud native kind of platform, it also works well with it too. And it's also open source. Yeah, so that's the nice thing about it too. And this one too, kind of explain a little bit, maybe kind of a little bit too much in here, but at least you kind of, I'll be sharing this this slide deck too, so you don't need to take notes of it or take picture. So as you can see, this RisingWave architecture in here, and actually over here too, yeah, as I kind of mentioned about it too, like a real world type of use cases, you can be doing like this kind of illustrate too, it actually can handle a lot of different kind of use cases too, like high frequency trading, IoT computing, fraud detection, network monitoring, all of these like ads recommendation too, stock trading, travel booking, all of these that requires like real world type of data and use cases too. You can also be thinking of using analytics database such as like RisingWave as well. Again, it integrates very well with the different messaging types of platforms as well. And then you also too, you can also leverage it, for example, for machine learning kind of training as well. Some accounting, more systems of record, you can also rely on it doing the job for you too. And this one is, again, because I won't have time to actually demo it, but you can also give it a try if you're SQL, if you're more familiar with it, you can actually use this SQL queries for doing like real-time analytics. And again, the key is that it makes use of materialized view, so then it holds the data in real time for you too. Okay, and then process the event streams with data. So you can see too, this example here, step one, you can create a source in RisingWave to receive like event streams from your Kafka topic. So it's pretty cool too. You can actually here, you can say create your particular cases, and essentially too, you are connecting it directly to Kafka. So it has also that type of capability. So you can actually stream your data immediately from Kafka topic as well. And then you can also then specify that continuous analytics logic with a real-time materialized view, as I kind of mentioned earlier. And then you can also be using SQL statements to be checking on the processing and monitoring the latest results as well. So those are kind of some advantages of if you're thinking of wanting something such as like RisingWave to do this work too, that can allow you to bring analytics to your operational databases in really near real time. Okay, so that's that, and I've explained that. And this one too, I was going to come up to is just an example too, because I realized yesterday, Ray East was actually at AWS here doing a talk, and then was talking about they integrate with the data lakes with Iceberg, Apache Iceberg. So that's pretty interesting. So they are doing more and more work to be integrating with various types of real-time operational data as well. Okay, so here, I won't kind of go way too over time because again, it's late. So just example kind of illustrate too, is basically in an AI kind of scenario. As I kind of mentioned earlier too, is that in AI scenario, we're talking about data, essentially AI is really rely on the data to do its work. So to me, I think there's a lot of like synergy between using event streaming data pipeline to help like AI type of scenario too. So here too, here I'm also trying to kind of just do a simple cases in which we can do a Twitter feed or X feed, and essentially to have any kind of data being captured, send it over to a Kafka topic, and then I have RisingWave already integrated with the Kafka topic because there could be certain types of tags that I'm tracking or kind of ordering some tags. And the most popular tag, I can extract that just for fun, right? I can extract that tag, and immediately too, I can also do a case in which I take the tag and essentially craft it up or enhance the prompt. And then with that particular enhanced prompt, I can just send it over to the LLM and ask questions too directly. So that will be kind of a simple case of illustrating use cases for this type of simple data pipeline cases too. Okay, so here too is just it's just kind of illustrating in a RAG type of application. You can also be kind of thinking of it, as a data pipeline type of scenario, data kind of going through different stages, working also with the vector database as well for doing RAGs. So that's that. And so I think then it comes to the end in here. So just wanting to share with you some resources. If you're interested, this slide deck can be accessed here. And I'll be sharing it too on the website as well, this bit.ly link, and upload that slide deck in PDF format. And also the QR code is here. So if you're interested. And then also, if you're interested in RisingWave, this is like RisingWave has their intro and also their, an example too. That's what I was going to try out, but not able to have time today. But it's a kind of an X events example that I was illustrating in that diagram too. If you're interested, you can take a look at that one. And then also I have my own stream on Twitch, and also I multi-stream to YouTube. But these days, I have to admit, I haven't had as much time to do streaming. But if you're interested, you can follow me too. I'm trying to go back to my streaming. And here, this is how you can keep in touch with me. I have my LinkedIn profile and my X, and also my Discord server too. And I welcome you to send me back any feedback, which is a QR code up top there on the right side. So with that, I want to thank you very much, and thank you so much for Divine for hosting me today. And thank you to everybody. Thank you.
Thank you. Does anyone have any question? Maybe you can take one question.
No.
Seems no question. Thank you.
Okay. Thank you. Thank you very much. Yeah.